Hello learners, welcome back to the C Programming lecture series. I Kirti Sharma, who am working as an assistant professor in St. Andrews Institute of Technology and Management, Gurugram. Today in this lecture series, we will discuss the decision making and branching statements. So in this particular topic, we have to cover the different types of statements, and on the basis of which we have to branch the statement and we have to take some conclusion, right? So if statement, then next we will study the if else statement, else if, later you can say or else if statement, then last is switch statement. There are the four types of the statement that we will study under the branching statements. So basically it's very important topic from final exam point of view, university exam point of view. So just mark this as important and continue the process of further lecture with the proper attention. Okay, so let's start with the decision making and branching. So right now, just it's a program. A program is a made up of simple statements like input output statement is there and assignment statement is there. So flow of execution also called as a control flow. So strictly sequentially execution of the statements whatever is written with the program, right? So basically branching statement, decision making statements work here on the input output and assignment statements. So flow of the execution is called as the control flow, you can say. That is strictly sequential. So when control of the flow is sequential, the statements are executed in order in which they appear in the program, right? So in the same manner, like programming constructs used alter the flow of control. So whatever is the flow of control, normal flow in a program from normal sequential execution, right? So it will alter the flow of control basically. So that's why it's called the control structure, right? So control structure is basically the who alter the which alter the flow of control in a program from normal sequential execution, right? So its behavior, what C program behavior is normal sequential execution, and it alter that behavior flow of the control, right? So that's why it's known as the control structure. Basically control structure is of three types. So how can you control the structure, the sequential execution of the normal sequential execution of the program? How can you control? So there are the three types for which, like conditional control transfer, that is also known as decision statement and branching. You have some decision, and on the basis of those decisions statements you have to branch the statements, right? So next is unconditional control transfer. You have to transfer the control unconditionally. Here you are transferring the control conditionally, but here unconditionally, right? So next is repetitive statements. That means looping. So there are three types of loop that we will discuss further, right? So these are the most important topics from the second unit of your syllabus. So just mark this thing and do it very well. Okay, so we will do these topics with the help of examples to give you the better understanding about the topics. So this is a flow of execution that we are seeing here, like starting of the statement, normal program execute is like this. All the statements whatever is written in the program will execute, and at last it will stop, right? So in order to move further, we have the first type of the control flow, that is decision making, or you can say conditional control transfer and branching, right? What it's mean actually, this control structure selects one of the two alternate segments of the program code. So what it's mean, two alternate segments of the program code are there, right? So this control structure selects the one of them, and it depends upon whether a given condition is true or false, right? So on the basis of the condition, either condition will be true or false. So on the basis of the true or false of the condition, the two alternate segment of programs are available, and on the basis of which conditions this control structure select the one of them, right? So basically we have to discuss the like if else statement, if statement, if else statement, the next is else if later statement, or next switch statement. Okay, so we will discuss each of them one by one with the help of example. So first of all, if statement. What is the if statement? It's a single if statement in the C language is used to execute the code. If condition is true, then it will execute the code whatever is written in the body of the if condition. If it is false, then it will come directly out of the form, like out of this whatever is the code is written in between the braces, it will never execute that code if this condition is false. So this is the syntax of the if statement. If statement, it is a keyword here, right? So I've already told you we will discuss the keywords one by one. 32 keywords are there in the C programming. So already we have covered over lots of the keywords. Here if is also a keyword. Its meaning is already preserved. User cannot use the if as a key as a variable name or any other by because it has its predefined meaning in the library. Okay. So if you have to written here if, then under the braces you have to write the expression. If the expression is true, then it will execute the statements whatever is written in between the braces. Otherwise it comes out of this particular block. Okay, so this is all about the if statement structure. Next we have flowchart. Flowchart of the flowchart of the if statement. It says that like you have to start the statement, then check the condition. If condition is true, then like you have to execute the if code whatever is written in between the braces of the if code. You have to execute that. If it is false, you have to come outside. After if whatever is written, all statement will execute, and then after you have to stop here, right? This is the flow chart. This is a program or example to get the better understanding about the if, right? So this is a program to check whether an entered number is even or not. Okay. So first of all, add the header files. The meaning of header files we have already discussed. Stadio.h standard input output header file, conio.h console input output header file. These are the basically input outputs to handle the input output. Standard input output, for standard input output, Stadio.h is available. For console input output, conio.h is available. So both the header files will take the control over the complete program. Whatever is predefined function, their meaning is already defined in these header files. That's why it's important to include these header files in the program. And this hash symbol is indicating the preprocessor. So working of the preprocessor and header files we have already discussed in the previous lectures. So here every program must have at least one function that should be your main function. At most any number possible. So void is the data type that we have declared here for this particular function main. So void means nothing is there in itself. So a user can take the input output accordingly as per the requirement. So no need to return at last anything. Okay. So because it's void, if you will return here int, then you have to return the integer at last. Okay. So here we are declaring a variable num that is equals to 0, which is of integer data type. Okay. So first we are printing here a message like enter a number. With the help of scanf function, standard input and output functions are there. So scanf is standard input function. This is output function. So percentage d. Here I am assigning the format specifier. Percentage d is indicating the integer. Like you have to use the integer here, right? So which type of the input you have to give here? Integer type input. In which variable? The number variable. And this ampersand is indicating the address. What in the memory you have booked a slot with the name number. You have booked the slot with the name number. This slot name is number and it is of integer type. That means 2 byte slots are available here. It may be like 32 bit. If your system is of 32 bit, then it will take 2 bytes. If your system is 64 bit, then it will take 4 bytes. So it's up to the system size. Okay. So it may be possible like integer may be of 2 bytes or 4 bytes. Here we are considering it as a 32 bit system. So I'm taking here 2 bytes. Okay. So percentage d is indicating integer value. Number is the name of the location and ampersand is indicating the address. At which particular address it need to give the input. So if here I provide the input as a 4 number of input. Okay. So the next is if statement is there. What is the number value? Number value is 4 here. 4 divided by 2. What is the remainder? This is the reminder's modulus symbol. It is equals to 0. If it is equals to 0, then you have to print here printf percentage d will indicate what the value of the number whatever it will be, right? So number value will be there as it is. It will print here like 4 will print here. Is 4 is even number, it will print over here as it is. So what it means, First it will check the condition. If it is true, it will read whatever is written in this block of the curly braces. If it is false, then it directly comes out of the this block. It will never read these statements which are written in between the braces. Okay, so what will be the output? If I are taking the enter a number, it will print a message 4 be entered as an input, then it will show the 4 is even number as output. So this is a program for the if. I hope it's clear to all. Like it's the program to check it out. You have entered a number, either it is a even or odd number. Okay, so here we have only checked the number, is it even or not. Okay, so next, in the next program, we have else if statement. So basically, there is a difference between else if and if else statement and if statement. What it is, if statement only check the condition. If it is true, then only execute the block of the statements, whatever is written in between the curly braces. If it is false, then it comes out and it reads the statements whatever is written in the else part, right? Like if you have already listened a kind of statements in the English language also, if you will study, then you will get pass, otherwise you will get fail. So what it's mean, you have the condition, if you will study, then you will pass, otherwise is extra option, like if you will not study, then you will not, then you will get fail, right? So here also, if else statement having the same thing, if it is satisfying the condition, that it will then it will execute the number of the block statement whatever is written here. If it is false, then it will execute the otherwise option that is written in the else part itself. Okay, so in the if, we were checking about the true part only. We are not taking considering in the else part or otherwise part in the if statement. Here we are considering the otherwise statements also. So this is the flowchart for the if else statement, where we have to check the condition. If it is true, it will execute the if code, whatever is written in between the if code, the number of statements in the block. Then after it will come out, and after the statements whatever is written, it will execute. Okay, but it is not true. If it is false, then it comes here and it will read the else part and execute all the statements whatever is written in the else block. Okay, so after that it will also execute the statements whatever is remaining in the program. All the statements will execute and terminate the program. So it was a discussion about the structure of the if else statement. Here we have the example. Like in previous example, we have written the program to check either a number is even. So a number is even or not, right? So it was just giving you the message, if the condition is true, then it is even, otherwise no any option, right? Here we have the otherwise option in the else part also. If it is not even, then last one option is it is odd number, right? So if a number is not even, not satisfying the condition, if it is false, condition is false, then it will come here in the else part always. Here we have taken the data type int, then that's why we are returning 0 here, integer, as an integer. It's indicating the successful execution of the program if we are returning the integer value here, right? So it will show the printout like output as enter a number. It will show a message here. You have to enter the number. I have written here 5. So 5 is the odd number. It will print here. If you will again execute the same program, it will take another number and it will show the message for it. Okay, you can do continue it for any number of the statements, any number of the values. Okay, so if you return here clear screen clr ser function, it will do the clear like previous values whatever you have execute return in the previous execution. So clr ser means clr stands for clear, ser stands for screen. That means clear screen, whatever is written previously you have to clear it out before execution of the current program. So you have to return this clear screen statement uh, after the declaration part. Okay, after the declaring of the variable. Okay, so it was the basics about the we have discussed if statement, if else statement. Next we have else if ladder. Ladder means you are repeating the same thing. That means we are only, that's why we have used the word ladder here, right? So else if ladder is, there is a difference between if else and else if that we will discuss here. else if statement is indicating here, like it is used to execute one code from multiple conditions. Okay, so if here we have used the syntax like if statement condition 1, if it is true then execute the statement. If it is not true then it will come here in the else if part. We have another condition. In the if else we have only one condition. If it is true then it will come here, otherwise else part will not have any condition here. That's the reason, that's the difference between else if and else if else only, right? In if else it didn't consist doesn't consist of any condition to check further, right? If condition of if is false then only one option is remaining here to execute the else doesn't else we will not check the any condition further, right? But in else if, that was all about the if else, right? In else if we have another condition in the else if part. So check it out. If it is false, then check the next condition. If it is false, then another check the next condition. You can repeat any number of times, right? At last you have to mention the else. If any condition, whatever the conditions you have written in the with the help of if and else if, all are wrong, all are false, then last option by default it will print the else part, otherwise option. Okay, so it's the difference between if else and else if ladder. Okay, but why it is ladder? Because you are repeating the you can repeat the else if part any number of times for any number of conditions. So to check the condition we can do it, check the condition repeatedly, right? So this is the flow chart for the else if ladder. Here we are repeating the conditions for like each and every time. If a condition is false we are going to check the another condition and so on. Whatever the if it is any of the condition is true, it will print or it will execute the block of the statement whatever is written in that particular block. Otherwise it will execute the last option else part and it will terminate the program. Okay, so it is a responsibility of the compiler to execute these syntax and rules or regulation in some manner. So next we have example for the else if ladder. Okay, so here we have declared a variable num0 and this is a program like num is any variable for which we have inserted some input. So whatever is the input you have inserted here, you have to check it out like in the if part. Is it equals to the 10 or not? We have checked it out here like it is equals to 10 or not. If it is equals to 10, it print here. It is not equals to 10, then check is the number is equals to 50. If it is 50, then print the statement whatever is written in this block. If it is false, then again come here. Then check the condition. If it is true, then come here and execute whatever is written in the block. If it is also false, then last option you have to come here on the else part only. Here no any condition is available. It's the else part only. Otherwise option. If all the previous conditions are not satisfied, that means number is not equals to 10, 50 and 100. It will print the same. And at last we have written here in return 0. Why? Because we have taken the main function as a integer data type. If we will return here void, then no need of this return 0 here. Okay, so it was all about the else if ladder. Next is switch statement. So before discussing the switch statement, first we'll discuss the need of the switch statement. Why we need the switch statement? We have already discussed the if else statement, right? So one potential problem is found in the if else statement, which is the complexity of the program, right? Complexity of the program increases there in the if else statement. Whenever number of alternative paths increases, we use the multiple if else construct like if else again and again, multiple nested time we have used. So it makes the program more complicated, more complex. So it may possible like to understand the program or read the program, it becomes difficult. So sometime it may also confuse the developer who himself wrote that code or the program, right? The solution for this problem is the switch statement itself. So to resolve the if else problem, like nested time it will use, and it will make the program complicated and very difficult to understand the programmer. So that's why error chances of the error may increases. So to give the solution to this problem, we have the switch statement here. So what about the switch statement? In C language, switch statement is basically used to execute the code from multiple conditions like else if ladder, right? So switch statement is you have to return here some statement or expression If this expression is true, then it will come under this particular block of the code. Otherwise, it will skip all this code, right? So if it is true, then only you will come under this block, okay? Then after you have to check the cases here, right? If switch is a condition is true, then you have to check the value here. Case 1 is true or not. If it is true, execute the value. And after each and every case, we have the break statement. This is the like conditional flow control statements that we will discuss later. Here it's mean only like if the case 1 is true and the statements whatever is written in the case 1 will execute, then it will break the complete session. Like whatever is written in the switch block, it will skip each and everything and it will come out of this block itself, okay? So if any case is true, in that case only we will do this thing. If any of the cases are not true, then by default case will print here. Whatever is the statement is printed here in the default, then it will print, execute this switch statement, and all the cases you have written. If any of the cases is true, then it will execute the statement whatever is written under this case, under that case, and leftover things will break by using the break statement. It will not execute. So all the statements, whatever is written in the switch will never execute. It depends on the cases. Like if any case is true, then only it will execute and it will directly come out after the execution of the statement whatever is written that particular specific case. It will never run all the cases. If if you have written break after each and every case, if you will not return the break, it is totally optional to use the break. If you will not use the break, it will continue read the all the cases. Who will continue it? It's the working of the compiler. Compiler will read each and every case and print the statements if you will not use the break. So it will not say like if you will not use the break, your program is wrong. No, synthetically your program is absolutely right. It will show the output, but intentionally, whatever is the intention to provide the output, it may fall, it may wrong, right? So according to the requirement, we can use these things. Okay. So next we have some rules. What is the rule here? First thing in the switch statement, expression whatever you will write, right? It should be an integer or a character type. Floating type or double or any other data type is not will not consider here, right? So only use the integer and character data type. Next thing, case value. So case 1, case 2, whatever you have written, either you have to take the integer and character constant there, right? You will use the constant. It is damn sure you will use the constant. So which type of the constant? Integer or character constant, right? So data type you can use in the switch statement during the expression or case only integer or character type, right? So in the break statement, switch case is not must, right? So you can use a break statement anywhere, like if else statement or in if else statement also you can use a break statement. Okay. So here is some example like int, char, float, declaration of the variables here. So use of the switch. Here we have declared the switch like switch x expression is there like here. Okay. So x is representing the expression here. So whatever is the value of the x, if it is true, then it will read the further things, otherwise not. So here some different of the expression that we expressed here with the help of the switch statement. X is greater than y, a plus b minus 2 function we have passed here. So these are the different types of the expression that you can pass over the switch statement. What about the case? Case should be, we have already discussed, it should be either integer or character constant. Here 3 is an integer now, we can directly write the constant as a 3 here. A is a character alphabet here, right? So we have to insert the character or alphabet within the single quote here. And we are considering it as a case. Next, you can write the expression 1 plus 2, right? So all are the valid things here, whatever is written. So it was a rule regulation about the switch statement that by following these rules, you can use the switch statement, okay? So we have the program regarding the switch statement here. So first we have created the variable my input here, data type with a char data type. 1 byte memory location it will take in the memory. So first we have given the message, which option will you choose? Program 1, A, program 2, B. So scan via with the help of inputs function scanf, you have to choose the value for the my input, and you can choose the value as A or B, right? That's why we have used here percentage C for char data type, right? So either you will use the case A in the switch statement if it is true, my input. Of course, it will be true. There will be some value. If there will no any value, then it will show false. So mostly times it will show true value. Then come here to check the case. Is your value, whatever you have written here in the my input, that character value, alphabet value is equals to A or not, or B or not? If it is equals to case A, then it will print the number of statement whatever is written in this block. Otherwise, it will print this one things, execute these statements. Okay. By default, if both are false, then it will execute this portion, right? So after the execution, it will come outside and return some integer here, right? So it was example for the switch statement. Next, we have this synthetical syntax to represent the switch statement. I think it's very simple. We have already discussed this thing. So to get the better understanding, I just written this block of the code and this flow chart also, right? So we have these options as a cases. At last, by default, case will print, and if after each and every block we have the break statement to execute, and at last we have to execute the statements whatever is remaining the program. So it is a flow chart of the switch statement. Next is a program. This is a program for the practice only, like to get the better understanding about the switch statement. Here we have taken the constant, we have declared a variable and passed the value as a 8 constant value, right? So switch statement num is here, that means 8. There is some value, that means if there is no any value, then it will show the false statement and it directly comes out. Here it is 8, that means some value is there. It will show 1, that means true. It will come here. It's not important like you each and every time you will start with the 1 only, 1, 2, 3. No, you can take any value for representing the case. Okay, integer, if we are taking integer, we are starting with the 7, 8, 9. Okay, so you can take any number, but it should be constant, right? So printf statement is executing, and here it is printing for the purpose like value is 7, value is 8. After each and every case we are using here break. Like if it is true, it will not read this remaining state cases here. It will directly come out of the scope, out of this block of the switch statement. Okay. If it is false, then after only it will check for the next one. And whenever it will get the past, like it will get the true statement, it will come directly out. It will not continue the cases. Okay, so output will be num is equals to 8. So this one case will match and it will print value is 8 and will break and come out. No, it will never read, the compiler will never read the leftover statements. Okay, so this was the example for the switch. So next one, a more example is there, in which I have just tried to declare one thing. If you are using the cases and you are not declaring any number of statements here for execution, it's okay. You are not using the break here, no any statement, it's okay. It will continue the cases. Either it is matching or not. Case 1 is matching or not. Not matching, then come out. Not matching, come out. If third, we have put it the value at 3. So it will print 1, 2 or 3 and it will get break. If it is true, then only. If case 3 is not true, then it will check for 5. In this particular example, our value of the number is 5, right? So here cases like 5 or not, we have to consider it this thing. Case 6, it will continue. Like either it is case 1 is true or false, it will 100% go to the case 2, right? If it will like never thought about it, either previous case is true or false, it always check the next one, either it is true or false. Okay, so why? Because we have not used the break statement here, right? After case 1, it will continue with the case 2, case 3. Like if it is case 3 is true, then it will break here after printing the statement. If case 3 is not true, then it comes to here for 4. Either case 4 is true or false, it doesn't matter. It always come for the case 5. Yes, it is equals to case 5. It also doesn't matter like it is equals to case 5, like it is true or not. It must check like next will also check, right? If it is checking the next 6, then it is not right. So it will continue the statements and it will print whatever it want to print. So if we will check for the 6, it will print 6. Like here it will come also. Either it is true or false. It will execute it also. So that's why it is printed. No need to confuse about the output. Like we have entered the value as 5, and here it is printing the value of the printf for case 6. Why is it so? Because case 5 is true, there is no problem, but it is doing continue with the case 6 also. Why is it so? Because there is no any break statement, it will do continue. No any statement is printed here, it will print the statement of the next case, because no any break statement is there. Here break statement is there, then it will come out of the box. Okay, so it was an important example to get the better clarity when to use the break statement, when to not the use the break statement, what is the requirement, and what is the uh, basic functionality of the switch statements we have discussed here. So in this session we have discussed all the branching statements, like we have some decision making statements, conditions on which we have branches of statements in the number of blocks and execute them, and we can also use a break statement. And further in lectures we will also discuss many more unconditional transfer like statements, control statements also will study, like break, go to, jump statements will be there. So we will discuss in the next lectures. So up to now, thank you and stay tuned with the lecture series. We will do continue from the next lecture to get the better understanding regarding the control flows. So in next lecture we will study the different types of the loops. So thank you, have a nice day.